All right, thank you so much for joining us today. And in this video, we have UIC Exam 1 Spring 2024 that we want to go through together. All right, let's start. So the first question is saying that using the limit definition of derivative, we should find f prime. So here it means that if you differentiate the function straight away, you are going to get it wrong, but it can guide us. So let's try and write f prime of x here and see what we are going to get so that we can work towards that. So using the power rule, we are going to have this one to be 4x minus 3. So it means that at the end of the day, when we use the limit definition, we should have 4x minus 3. That is the goal. So that is one thing I like about limit definition. I can differentiate the function and then I know where I'm working towards. So let's go through. Now what is f prime of x using the limit definition? H is approaching 0, f of x plus h minus f of x divided by h. Right? F of x is given, which is 2x squared minus 3x plus 5. So as I said, I like writing this one and putting all my x in parentheses so that it can help me find f of x plus h. So I put all the x in parentheses so that now when I'm finding for f of x plus h, now x is in parentheses here, x is in parentheses here, x is in parentheses here. So I'm going to write the same thing for this one, but all those in parentheses now will change to x plus h. So I'm going to have 2x plus h squared minus 3x plus h plus 5. So now you can see that x plus h is here, x plus h is here, x plus h is here. As we can see, x is here, x is here, x is here. So the same thing here, the same thing here. The only difference is this is x matching with this x plus h matching with this x plus h here. So let's try and simplify x plus h. So this is the same as x plus h minus 3x minus 3h plus 5. Let's simplify. 2 x squared plus x8 plus x8 plus h squared, right? So I'm just simplifying this. X times x times h, 8 times x, and then 8 times h, minus 3x minus 3h plus 5. Let's multiply through by 2, but let me simplify the middle one first. 2x8 plus h squared minus 3x 3h plus 5. So we are going to have 2x squared plus 4x8 plus 2h squared minus 3x minus 3h plus 5. Can we cancel something out? No, we cannot do any cancellation here. So now we have f of x plus h and we have f of x. So instead of writing all of them with the limit, what I'm going to do is I'm going to find for f of x plus h minus f of x. Then the results, I will just come and put it there, right? So let me just clean this, clean that, clean this, and clean that. And then just bring this guy up here. So that is our f of f plus h. So f of x plus h minus f of x will be equal to the whole of this minus the whole of that. So we are going to have 2x squared plus 4x8 plus 2h squared minus 3x minus 3h plus 5 minus, I open my parenthesis. What is f of x? F of x is here. So I'm going to have 2x squared minus 3x plus 5. Let's simplify. 2x squared plus 4xh plus 2h squared minus 3h plus 5 minus 2x squared plus 3x minus 5. So the magic will happen. Minus 5 and 5. Positive 3x minus 3x. Okay, let me use different colors to do that. this and this one to go out, and then minus 2x squared, and this one to be going. So it will be left with 4xh plus 2h squared minus 3h. That is beautiful. Now we can see that we have h here, h here, h here. I can factor one of the h out. So I can factor h out, and then this one will be 4x plus 2h minus 3. So I just factored h out because of this guy here, right? So now finally, what can we get? This is equal to limit h is approaching 0. Now the f of x plus h minus f of x is what we've gotten here. So we can replace that one by h 4x plus 2h minus 3 divided by h. So you see, when I do that one, it's very simple for me to not write in the limit, the whole of distance, like a lot. So simplify and come and just put it in there. And then the magic happens, this will cancel that. So what are we going to get at the end of the day? Let me try and bring this one down small. So what are we getting at the end of the day? This will be limit h is approaching 0, 4x plus 2h minus 3. Now that what is worrying us, which is h here, is gone, we can plug in the 0, and guess what? This will be equal to 4x plus 2 times 0 minus 3, and this is going to give us 4x minus 3. Guess is what is happening here. Yes, so that's where we needed to go. So this one helps me to check if I had the right results. So if I don't get this to be the same as this, then maybe maybe I didn't put this one in parentheses, and then I just had this one to be this without changing this one to positive and this one to negative. So it will help me to go through the whole solution to check where the mistake happened. So now that this is equal to this, then my f prime is equal to that. Now the question is, what is the slope of tangent at x is equal to minus 2? So that is actually, we are looking for f prime of minus 2. But we know that f prime of x was equal to 4x minus 3. So the slope is this at x is equal to minus 2 is when we plug in minus 2 into this. So we are going to have 4 times minus 2 minus 3, and this is minus 8 minus 3, and this is going to give us a big minus 11. And then C is asking us to find the equation of the tangent. So we know that the equation of the tangent, we have it in different form. You can write it as y minus y1 is equal to the slope x minus x1, or you can also write y minus f of x1 is equal to f prime of x1 x minus x1. Any of them works, right? So now our x is equal to minus 2 here is the x1. If I'm using the second one, this is x1, which is equal to minus 2. So what I need to do is I need to just do substitution. So I'll have y minus f of minus 2 is equal to f prime of minus 2 x minus 2. So I know f prime of minus 2 to be minus 11. And don't forget, if we are not using this formula here, so let me just shift this one aside somewhere here. So if we are using this formula here, then your m here is equal to minus 11, and your x1 is also equal to minus 2. So what we need to do now is we all need to find y1, right? So when I simplify the one here, I'll have y minus f of minus 2 is equal to minus 11x plus 2. So when you do substitution here too, you are going to have y minus y1 is equal to minus 11. Put this one there, then you have this. So you see that this is the same as this. We need to find f of minus 2. We need to find y1. But you see, when I'm using this one helps me to see what I'm looking for. I need to look for f of minus 2. So I just come to f of x and I plug in minus 2. But if I'm here, then I need to look for y1 by putting this one also still inside this. And then I'll have my f of 2. So let's do that. What is f of minus 2? Remember, f of minus 2 is the same as y1. So this is going to be, let me plug in minus 2 inside this and let's just send it there. So we are going to have f of minus 2 to be equal to 2 minus 2 squared minus 3 times 2 plus 5. So minus 2 squared is 4. 4 times 2 is 8. Then this one will be plus 6 plus 5. And this is going to give us, I think, should be 19. Good. So this is equal to 19. And this is also equal to 19. So if I'm using this one, I'm going to have y minus 19 is equal to, when I multiply this one, I have minus 11 minus 22. So this will be my solution for equation of the tangent. If I'm using the one here, then this one is going to be y minus 19, which is equal to minus 11x minus 22, which is the same as this one here. So any of them that you use is right, but the idea is that which one do you use and when should I use them? You get it? That is very important. So mostly I use this when the function given to me is like kind of f of x, right? And then I use this ones to when I have the function to be, let's say, y. So if this one was y, then it's better for me to use the one here. Good. Let's look at the next question. Find the derivative of the following function. Do not simplify your answers, right? So let's try and do that. So this one we are going to use the power rule. So f prime of x will be equal to 8, right? So power rule, 8 is a constant. I maintain it. Then I differentiate 5, x to the power 5. So 5 drops down. Then I have 5 minus 1. Minus 10 out. I differentiate x squared. I have 2, 2 minus 1. Plus I factor 6 out. When I differentiate x, we know that we are going to get 1. So you then just write 1. And when I differentiate a constant, I get 0. So this is going to give us 4, 0, x to the power 4 minus 2, 0, x plus 6. So this is what you are going to get for the results. Now with this one, for us to do it, we need to simplify, right? So you see that this one was in the form of a polynomial function, so there was no simplification before we did it. We just did the differentiation straight. But this one we need to simplify. We can write this one as 8 x to the power 1 over 2 minus 2 x to the power minus 5. Now when you do this, then this is kind of in the form of also a polynomial function with the powers. So now we can now find gen prime. So what will be gen prime? Gen prime of x will be equal to, so let's use the power rule. Half will drop down. So I'm going to have 8 times 1 over 2 x 1 over 2 minus 1. Then minus 5 times minus 5 x to the power minus 5 minus 1. So that is the power rule. Let's simplify that. This will be 4x. And then this one, when I subtract, I'm going to have negative 1 over 2. Then plus 1, 0, x to the power minus 6. So this is what I'm going to also get for this. Right, so that is question 2. Let's look at 3. Evaluate the following limit. So one thing about limit is anytime you see a limit question, the first thing that you just need to do is do direct substitution. When you do direct substitution and it is not working, then you think about other ways of doing limit. So the first thing I'm going to do is I'm just going to plug in the value in and see what is going to happen. If I get the answer, Then I move to my next question. If I don't get it, then I think about different ones. So this is going to be minus 3 times 2 plus 1 divided by 8 times 2 squared plus 1. The top will be minus 6 plus 1 divided by, 2 squared is 4 plus 1. So the top is minus 5. What is 8 times 4? I think 32 plus 1. And this should be minus 5 divided by 33. So you see that when we did this one, there is no, you know, undefined or something that we had. So this is right. I don't need to do anything again. I've gotten my final results. I'm done. So that is basically what you just need to do first. Right. This one too, the first thing that I need to do is I need to do direct substitution. But always when you are doing direct substitution, you need to think about the denominator, because when the denominator is 0, that's when the problem is. So let me just do the denominator. Put it at the denominator. You get 3 squared minus 9, and 9 minus 9 will be equal to 0. So I don't like it when the denominator is 0. So it means that here direct substitution is not going to work for us. So we need to do some factorization and try to do that. So let me pick x squared plus 2x plus 5. Let's do factorization here. So basically, the coefficient of this is 1. So 1 times 5 is going to give us 5. So let's look at factors of 5. So I start with 1. What number when I multiply by 1, I'll get 5. That is 5, right? Oh, it's supposed to be minus 15. Oops. So this is minus 15. So as I said, 1 times minus 15 is going to give us minus 50. But let me pick the 15 if we want to do factors. So I ask myself, I start from 1. 1 times what is going to give me 15? 1 times 15. Then I ask myself, 1 times 15 is 15. Can I add or subtract this and get 2? No. So if because of that, I need to move to the next one. I need to move to from 1, I need to go to 2. Can I multiply 2 by any number and get 15? No. So that is not going to work. So since 2 is not working, I need to move to the next number. What is 3? Can I multiply 3 by any number and get 15? Yes. That is 5. So 3, 5, 15. I don't need to move to 4. What I need to do is now when I multiply 3 to 5, I'll get 15. But I ask myself, can I add or subtract and get 2? Yes. If I do 3 plus this, I'm going to get 8. But if I do 3 minus this, I'm going to get minus. But I can do 5 minus 3, and I'm going to have this. So this will help me to find the factors of that. So that is ways of finding factors of your function. So what I'm doing is, since I want to get positive here, I need to do 5 minus 3. So I'm going to do 5 minus 3. But I'm not just getting 2, I'm getting 2x. So what I'm going to do is I'll add x to this, x to this. So that 5x minus 3x is going to give me this. So I'm going to have x squared plus 5x minus 3x minus 15. Good. So that now I can simplify. So let me pick this one together and pick this one two together. So the first one with the blue, when I factor x out, I'm going to have x plus 5. And then the one with the red, when I factor minus 3 out, I'll have x plus 5. Now we can see that the one with the green, this is here, this is here. So it's kind of like you having something like AB minus AB, right? Or let me say CB. So you can see that B is here, B is here. So we can factor B out and it will be left with A minus C. So same thing that we want to do up there. So the one with the green, we can see that x plus 5 is on both sides. So when I factor it out, it will be left with x minus 3. So it means at the top, the factor is x plus 5, x minus 3. So that's what we just need. So we just need that. Just shift this one up somewhere here. Good. So the top is going to be limit x is approaching 3, x plus 5, x minus 3, divided by Now x squared plus x squared minus 9 is difference of two squares, like x squared minus 3 squared. So this is the same as x plus 3, x minus 3. And then we see that this will cancel that. So what will happen next? Limit x is approaching 3, x plus 5 over x plus 3. Now, anytime we have a fraction, we worried about the denominator. So now when I plug in 3 here, this is not going to get to 0. So now I can do substitution now. So this will be 3 plus 5 divided by 3 plus 3. And this should give me 8 divided by 6. And I can say that this is the same as 4 divided by 3 as my final results. Okay, so that's what I'm going to get. Now let's look at C. Let's look at C. C, we want to find limit as x is approaching infinity. Anytime x is approaching infinity, we are thinking of horizontal asymptote, right? So we need to think about how we deal with horizontal asymptote. Anytime we are dealing with horizontal asymptote, we try to compare the degrees, right? So this limit here will reduce to limit as s is approaching infinity. We need to look at the top. We need to pick the term with the highest degree. So we can see that the term with the highest degree is 6x to the power 4. So that's what we just need to do. Then we come look at the denominator. We pick the one with the highest degree, which is negative 3x to the power 4. Unfortunate for us, this is limit x is approaching infinity. Now 4x will cancel 4x. So we are going to have 6 divided by minus 3. Limit x is approaching infinity will be minus 2, right? And then now limit of a constant is the constant. So this is going to give us minus 2. So if you remember horizontal asymptote, if we wanted to find the horizontal asymptote, we are going to say, look at the one with the highest degree. So since the highest degrees are the same, we pick the coefficients, right? So this one is going to be minus 6 divided by, 3, 6 divided by minus 3, and this is going to give us minus 2, which is the same as what we have here. So this is what you can do whenever you are dealing with x is approaching infinity. Let's look at the next question. So the next question here, we want to sketch, right? We want to use the above information to do some graph sketching. And as I said, anytime you have a question like that, the first thing that you might think of doing is do the one with f of something is equal to something. That one is easy to do, right? So I know that f of minus 1 is equal to 1. So what is minus 1? Minus 1 is here and is equal to 1. So I'm going to have something like this here. So you see that I'm using the one that I need to shade in because the idea is that it is f of minus 1 is so it is included, right? Then the next thing that I need to do is, okay, since that I've gotten the first one, I need to look at the one that x is approaching a specific value here. So we can see that x is approaching 0. And as I said, if x is approaching 0 and is equal to 0 and it exists, then this limit here implies that limit as s is approaching 0 from the left of f of x is also equal to 0, and limit as s is approaching 0 from the positive of f of x is equal to 0. Because we can conclude that this is equal to 0 when the left and then the right are the same. Is that right? So I'll just come to where the 0 is. This is where I can find my 0. So my 0, it means that there will be a graph going this, there will be a graph also going this, because when I'm approaching from the let me do this one well. I will have a graph coming up to 0. I have another one coming up to 0. Because when I'm approaching from the left, when I'm approaching it from the left, I'm getting 0. When I'm approaching from the right too, I'm getting it 0. This and this. And it will convert to 0 and it give me this. So I'm not drawing the graph. I'm just sketching something. I know that I need to convert to 0 there. So I'm also done, working with this. Now let's look at this. This is just telling us that from the negative one, from the negative side. So this one, we don't need to have something like this because this is telling us we are from the negative. So negative one from the negative. So from the negative, the negative side is the left side of negative one. So here. So from the negative, we are having negative one. So from the negative, we are going to have something here. So we are going to have something here, right? So let me just have something there. So we are approaching from the negative. So I don't even know what is happening there. So from this one, I'm going here, right? So that is what is happening because from the negative, or let me say, when I'm approaching it from the negative, I'm just coming to this, right? Because when I'm approaching negative one from the negative side, I'm going up to negative one. So this is negative one, and I need to approach it to negative one. When you finish, we'll join them together. So I'm done with this guy to here. Then when it is positive, positive means that I'm from the positive side. So positive means that I'm from the right side of this. So I'm from the right side, it means that I'm moving towards something like this, right? So I'm moving towards the one here, which is the negative one here, but it's supposed to be on one. So we have gotten something also from there. Then when x is approaching infinity, I should be getting 0. So it means that what are the x value here? For you to do the last one, which is x is approaching infinity, you need to look at the x values. So what are the x values? 0 and negative 1. So negative 1 and 0. So it means that when x is approaching infinity, it will start from when it is the last value of 0, which is the positive value of 0. Sorry, the x, which is 0. So from 0, everything goes to infinity. And when it's going to infinity, it's going to go to 0. So when we get to 0, it means that when we are starting from 0, the graph is going to be getting close to 0. So we are also done with this. Now let's put them together. Now we can see that at negative 1, there is something like a jump discontinuity. So since the point 1 is here, it means that since this one is shaded, this one should be a hole. So let me just now draw the graph. Very nice. So this one is going to be a hole like this, and then it will be just going this way. So I'm going to have something like this. Just shape this one like this. Good. So I'm going to have a graph like this, right? So when I'm coming to negative 1 from the negative side, I'll get this. Then let's look at this. Now you see that there is a graph coming from the negative towards this, right? And there is a graph also going this. So I need to combine this and this together, right? So that it will go together. Like meaning that when I'm coming from the left, I come here, and when I'm coming to the right, I goes to this way. So I clean this, and I also clean this graph here, and this is going to be something like that, right? Something like this. Because this tells me that when I'm coming from the negative side of 0, I get to 0. And when I'm going positive side of negative 1, 2, I get to this place. So you see the way I'm combining the graph. And then here to when I'm coming from the positive side, I'm getting to 0. But when I'm going to negative infinity, I should be getting 0. So it means that I can combine these two here, and I need to have something getting close to 0. I mean, you should be able to be on the x-axis, and you are getting to 0 when x is approaching what? Infinity. So this is what you are going to get for the graph of this when you are doing them. So what you need to do is, whenever you want to draw the graph, you don't sketch it like I see this one, so I just sketch it like this way, or I see this one, I just sketch it this way. You just try to give them some tails. So when you finish them, you combine them together. Is that right? Yes. So this is question 4. Let's look at question 5. Given this, find the average rate of change over the following interval. So we know the formula for finding average rate of change, right? So average rate of change is equal to, so this is going to give us gain of B minus gain of A divided by B minus A. This is the formula, right? Where this is our A and this is our B. So we are going to have gain of 3 minus gain of 1 divided by 3 minus 1, and this is going to be gain of 3 minus gain of 1 divided by 2. So let's look for gain of 3. Gain of 3 is going to be 3 squared minus 5. So I'm just doing substitution here. So this is going to give us 3 times 9 minus 5. This is 27 minus 5, and this should give us 22. So what will be gain of 1? Gain of 1 will be equal to 3 1 squared minus 5, and this is going to be 3 times 1 minus 5, and this will be 3 minus 5, and this should give us minus 2. So now let's find the the formula, right? So we know that the average rate of change, let me just put this one on the top. Let me make it small size and put it on the top here. So that is average rate of change, and then let's work with what we are looking for here. Okay. So now gain of 3 is equal to 22 minus gain of 1 is minus 2 divided by 2. So we are going to have 22 plus 2 divided by 2. This is supposed to be 24 divided by 2, and we should get 12. So this is going to give us 12 at the end of the day. Let's look for this. So this is going to give us gain of 2 minus gain of minus 1 divided by 2 minus minus 1. So this should be gain of 2 minus gain of minus 1 divided by 2 plus 1, right? And this is going to give us gain of 2 minus gain of minus 1 divided by 3. So let's look for gain of 2 and gain of minus 1. So let's do that. Gain of 2 will be equal to 2 squared minus 5. 2 squared is 4 times this is going to give us 12. 12 minus 5 should give us 7. Yeah. And then minus 1 is going to be 3 times minus 1 squared minus 5. So this is going to be 3 minus 5, and this is going to give us negative 2. Right. So let's try and plug them in. So this is going to be 7 minus minus 2 divided by 3. And this is going to be 7 plus 2 divided by 3. This is 9 divided by 3, which is going to be 3. So this is going to give us 3 from there. Good. So that is question 5, average rate of change. Let's look at question 8. So what is the notation for the left hand limit of f of x as x is approaching negative 3? So x is approaching negative 3, but we don't see the left. The left means that we need to see negative on the top. This is positive. So basically, the results that we need to do should be this. So this should be the results. This should be 1. Then assume that limit of this is equal to 0, and this is equal to 0. Which limit below does not have to be equal to 0? So this will be 0, because when I expand, this will be equal to 0. This one will be 0. This one will be. This is going to be undefined. So this is not the one that's going to hold. And if you want to look at this, this is like the properties of limit. If I want to use this, if I just want to do this one, you see that I'll have limit x approaching 3 of f of x plus limit x is approaching 3 of gen of x. Now we know that this is 0 and this is also 0. So 0 plus 0 will be equal to 0. So this is true. when you do the minus, this one will be just minus, right? So it will be 0 minus 0, and this one will be true. When I'm dealing with the dots, this one now become multiplication, and this is 0, this is also going to be 0, and this is true. But look at this one, because it's divided by, this one will be divided by what we have here, and this is going to be 0 divided by 0, and 0 divided by 0 is not 0, so this is not true, right? So that's supposed to be the one. Now let's look at this one, true or false. Now if x is in the domain of this, then this must exist. This is false, because it's not always the case that if x is in the domain, when you pick the limit, it's going to be defined, right? So basically that is how it's supposed to be, because for this to be defined, then the left and then the right should be the same, right? So it can be that they are all in the domain. For example, let's assume that um, let me say f of x is equal to, let's say, 1 2 3, right? And then this is when x is, let's say, less than 5, and this is when x is equal to 5, and this is when x is greater than 5. Then what is the limit as x is approaching 5 from the left of f of x? So from the left means that 5 should be less than 5, and this is equal to 1. What is the limit as x is approaching 5 from the positive of f of x? It means that this one should be greater than 5, and that one is equal to 3. So you see that this and this are not the same, and we can conclude that the limit does not exist. So this one can be true, but it's not always. So since it is not always, then we need to pick false, right? Good. So that's the idea with the C. Let's look at D. If this is equal to -6 and this is also equal to -6, then what will be this? So the left is the same as the right. So this one too should be equal to -6. So this is going to be this one. So that will be question 6. Let's look at question 7. So question 7, we want to look at the revenue given X and then the cost. Always pay attention to what is here, right? So when you pay attention to what is here, that is what's going to help you to know what you are doing. Now we can see that we are talking about R of X. Since this is X, it means that the function should be in terms of X. Now we know that revenue is equal to X times P. So it means that here, since this one is in terms of X, we need to look for P. If you see R of P is equal to X times P. Now note here that here this is P, so we need to make sure we need to replace the X so that everything will be in terms of P. This one is X, so we need to replace the P so that everything will be in terms of X. So if this one was the one that we are looking for, then we have X here. We need to come and place this one here so that we have something like 150 minus 5P times P. So that now this is P, everything here too is P. But this is X, so we need to replace the P. So that is what you need to pay attention to. So since this is in terms of X, then we need to look for P, and we can look for P from here. So this is going to be X is equal to 150 minus P. So I'll move this one to this side, I move this one to this side. So I'm going to have 5P is equal to 150 minus X. Divide through by 5, and you get 150 minus X divided by 5. So now I plug that one in here, and I'm going to have X times 150 minus X divided by 5. And if I want to simplify this, I'm going to have something like this. This is kind of divided by 1, right? So this will multiply the top and this will multiply the down. So this is going to give us 150x minus x squared divided by 5. So this will be the revenue function, which is in terms of x. Now let's look at the next question here. The next question here is, if 10 items are currently being produced. Estimate the change in revenue producing one more item using the marginal revenue. So anytime we are talking about marginal revenue, then we are talking about the derivative, right? So marginal revenue is R prime of X. So what is R prime of X? We need to differentiate this function here. Now, this is kind of, I can write this one as 1 over 5 times 150x minus x squared. So 1 over 5 is a constant, right? So 1 over 5 is a constant. Then I differentiate what is inside the bracket. I'll have 150 minus 2x. Good. So now this is when s is equal to 10 because x is the quantity which is here. So I'm going to have r prime of 10 to be equal to 1 over 5, 150 minus 2 times 10. And this should be 1 over 5, 150 minus 20, 1 over 5. When I subtract 20, I'll have 130. And I think this one should be 26, I think. Yes, because 5 times 6 is 30, which will be 0, and 3, 10. Yeah, so this should give us 26 at the end of the day. Now find the profit function and the marginal function. Okay, so what is profit? We know that profit is equal to revenue minus cost. So what is the revenue? What do you get for revenue? Revenue was 1 divided by 5, 150 minus 2x minus what is cost? Cost is 400 plus 10x. So let's try and simplify this. What I can do is I can divide this through. So I'm going to have 150 divided by 5 should be, I think, 30 minus 2 on 5x minus 400 minus 10x. So this should be, now this and this is going to be minus 370. Oh, this one's supposed to be x. Yeah, this one's supposed to be x. 150 here should be with x, so this one will be 30x. Good. 30x. Oh, and this one too is so bad. I was using r prime instead of, oops. I think I was using r prime instead of let me just do this one again. So r of x should be 1 over 5 150x minus x squared. Yeah, so this is right now. So this is going to give us 30x minus x squared divided by 5 minus 400 minus 10x. And when I simplify this, I'm going to have, is it, yeah, 20x minus x squared divided by 5 minus 400. Yeah, so this is what I need to get for p of x, which is the profit function. Then when I want to find the marginal, so the marginal is just differentiating the profit, and this should give us 20 minus 2x over 5. Yeah, so this will be the marginal profit. Good. Let's look at 8. Now assume C is the cost function in dollars of a company producing X items. If C of 150 is equal to 16,000 and then the marginal cost of 150 items is 120, then what is the estimated cost of selling the items? So basically the information that we are having here is C of 150 is equal to 16,000, and then C prime, because this is marginal cost, so C prime is equal to 120. So what we are looking for is we are looking for C of 160, right? And this is approximately C of 150 plus C prime of 150, then 160 minus 150. So this is the formula for doing the estimation. So this is going to be, what is C of 150? That is 16,000 plus C prime is 120, and this one is going to be 10. So this is going to be 16,000 plus this one will be good. And when we add, what are we going to get? I think 2,800 and I said 2,028,000. Is that right? No, it shouldn't be 28,000 because it is not up to that. This is, if I put the comma here, okay. So this one should be 17,200. Good. 17,200. So that's what you are going to get for question 8. Let's look at question 9. Okay, so if f prime of A is positive, then f of s is, I think, increasing. Yeah. So when you are using the line sign chart and you find f prime, you put A inside and it's positive, then we have the increasing aspect, right? So this is what we are just trying to say. So let's assume that this is 0 and I pick f prime of A and it's positive. Now remember, this is positive means that it's increasing. And then since we have negative here, so this is going to be decreasing. So if I pick f of A and that one is less than 0, and this is going to be minus and to be decreasing. So using the sign chart. Now let's look at C. Consider the y which is equal to f of x below. State the x value or values where f prime is equal to 0. So f prime is equal to 0 is where we are at the maximum, right? So what will be the x value there? X value will be 1. So here is when x is equal to 1. So this one is asking us x value of values. If we have the graph to be, let's say, this and going this, so it means that we are going to have another one here. But this is just one curve, so this is what you are going to have at the end of the day. So x should be 1. On the graph above, sketch the tangent line to y f of x at x is equal to 3. So x is equal to 3 is somewhere here. So this should be, we should be having something like this tangent line. So we are trying to draw a tangent line. Good. So this should be getting close to 3. Good. So that is the tangent line that we are looking for. So sketching this is the question D. Good. E, on the blank axis provided below, sketch f prime of x. Okay, so I think we need to sketch this one. What we can do is we can pick some points. So we can see that the point here is minus 1 and 0. On this point we have 1 and 2, And then this point we have 3 and 0, and then we try to find the slope. So let's pick the point. We have -1 and 0, we have 2, we have 1 2, and then we have 1 2 and 3 and 0. So let's find the slope so that we can do with that. But basically we can see that since the graph is of this form, right, when you divide it into 2, you can see that this aspect is kind of increasing and this aspect is kind of decreasing. But let me find the slope here. What will be the slope for this one? It's going to be 2, is going to be 0 minus 2 divided by 3 minus 1, and this is going to be minus 2 divided by 2, and this is going to be -1. What will be the slope for the first one? 2 minus 0 divided by 1 minus minus will be positive, and this will be 2 divided by 2, which is equal to 1. So the slope for this side should be 1, right? So kind of constant there. So this one, the slope for this one should be 1, and then the slope for this side should be equal to -1. So it means that we are going to have a point, 1 here and 1 here. You should be having something nice, beautiful, like this. Good. But I can shift this one into the lines. Good. So this is what we are going to get for the equation. Very nice here. So this side is increasing and this one is also decreasing as well from where the equation of the slope is. Now we can see that at x is equal to 1, so it means that when you plug in this one here, you are going to get 0 from the function, because that is when you are getting close to. So at this tangent line, you should be getting 0, because the idea is that when I plug in, when I have, you can see that f of 1 is equal to 2 from here. And when I differentiate this, f prime of 1, this is going to 0. So you see that at this point, we are getting it to be 0. Good. So that will be I think the last question for the day. All right. So see you in the next video.